Hey 7th graders, today I'm going to talk to you about something called the Triangle Sum Theorem. And what it is a theorem that proves that the measures of all three angles in the triangle are equal to 180 degrees. We've talked about how a straight angle is 180 degrees, and you can see I have all these different triangles. I have a right triangle, I have an acute triangle here, I have an obtuse triangle here. And all three of these angles equal 180 degrees. And I can prove that by ripping the angles off and lining those angles up, and they will all meet up and be 180 degrees. Straight line there, that was my acute triangle. Here's my obtuse triangle. Again, so I can take this angle measurement, line it up, this angle, line it up, and my third angle, line it up. It's kind of like a puzzle. It will all get in there, and it will make a straight line. Last one here is my right triangle. You can see my right angle here. There's angle 1, angle 2, so angle 3 would have to be the final one that proves that all three angles equal 180 degrees. And that's the Triangle Sum Theorem proof. Okay, and we could use that to work out some math problems. So we know how to find the missing measures using the Triangle Sum Theorem. If I know that angle X, Y, and Z when added have to equal 180 degrees, then I can set things up to be equal to 180 degrees. So here in example A, it says find each value of X, then classify each triangle, which we can worry about in a minute. So I can see here that this one says 28 degrees, this one says 50 degrees, and this is X degrees. So I can set up an equation. It says 28 plus 50 plus X equals 180. And then I can just begin to simplify. 28 plus 50 is 78 plus X equals 180. Subtract 78 from both sides. So X is equal to 102 degrees. So that angle right there is 102 degrees, which is an obtuse angle, which makes this an obtuse triangle. And all three sides are different lengths, so it's an obtuse scalene triangle. And so that's how you do that. Here's example B. This is a right triangle. These little marks here and here tell me that it's isosceles. So I know it's a right isosceles triangle. And because I know it's isosceles, this angle here has to be 45 degrees because this is 90. 45 and 45 is 90, and 90 and 90 is 180. But I can set up an equation to prove it. So 90 plus 45 plus X equals 180. 90 and 45 together is 135 plus X equals 180. Subtract 135 from both sides. X is equal to 45, and there's your proof right there. So that's how you find the missing measures of some pretty simple triangles. Down here, make sure you guys can see this. It says find angle measures. Again, these are just stepping it up a notch, making it a little bit harder. And then classify as well, which we can classify right away already. This 128 degree angle here tells me that it's obtuse. And this little mark here and this little mark here tell me that those are the same length. Those are congruent sides, so this is isosceles triangle. So here I have an X and 128. So I have X plus 128 degrees is equal to 180 degrees. Combine your like terms here. Okay, so that's 2x plus 128 equals 180. Subtract 128 from both sides. 2x is equal to 52. Running out of room, sorry. Divide both sides by 2. X is equal to 26. So it's just going back to our equation work, which means this angle here is 26 degrees and this angle here is 26 degrees because 26, 128, and 26 equal 180. Alrighty, so I have this triangle right here. Looks pretty equilateral, but we can prove it. So I have x and x, so together I have 2 x's plus 60 degrees equals 180. Subtract 60 from both sides. 2x is equal to 120. Divide both sides by 2. And x is in fact 60 degrees. So if this is 60 degrees, this is 60 degrees, and this is 60 degrees, it is an equilateral triangle. So this is the triangle sum theorem. Again, it means the sum of the angle measures of a triangle equal 180 degrees. Every triangle will be that way. If they don't equal 180 degrees, it is not a triangle. Okay, hope this helps.